Okay, so Madhukar, if you can start recording.
Yes, I started.
Okay, so good morning, everyone. So today we'll try to cover two topics. One, we will talk about something called Redcap in 5G, 5G Redcap. So Redcap is nothing but reduced capabilities of 5G in order to support certain smaller devices, the devices which cannot be prepared in respect of size, in respect of complexity. If you cannot build that kind of a device, then we will use this red cap capabilities, which is coming in 5G. So as we know that in 5G, we have three usage scenarios. The first, we call it enhanced mobile broadband. Then the second usage scenario, we call it ultra reliable low latency communications. And the third one is massive machine type communications. We have gone through the capabilities required to support these three scenarios. But just think about that whether all the devices, all the IoT devices really need such a high feature of EMBB, URLNC, and MMTC? Answer is no. For example, if you have a smart watch uh, connecting on 5G network, you may not require all these features. So you require certain smaller part of the feature, and that's how the concept of RedCap came, that we can have a reduced capability device connected on 5G network, and it can still do whatever it is intended to do. So that's the RedCap concept of RedCap which we have. Now let's look at different type of IoT services. So up till now, we had been talking about massive IoT, massive machine type communications or massive IoT. So basically, they are like applications like smart metering or asset management, where you only require coverage and connectivity. You do not require much speed, much latency in a environment which is smart metering and asset management. Even the agricultural field sensors are like massive IoT type. So we look at low cost devices, low energy, that means energy efficiency, very less data, but number would be less. But there are now applications coming up which are kind of a broadband IoT. So broadband IoT, some example can be if I have a 5G device on a drone and it is able to take pictures, video from the field. So it's kind of a broadband IoT which is transmitting a video signal or image signal to the server. So here similar is the example of AR/VR. AR/VR would also require a slightly high data rate because we need to transfer multiple layers of video audio transmissions. So here requirement is of high throughput, latency requirement is also important, and data is required is also very high. So these are kind of a broadband IoT. And then we have a critical IoT where URLLC becomes very important. So as we know that the autonomous car or intelligent transport system, as we call it, would require a very high level of latency and reliability, that is URLLC. Similarly, traffic safety and control would also require certain precision. So these are like ultra reliability, low latency, and high availability. And finally, we have industrial IoT, industrial automation IoT. So where you need advanced control and automation, advanced level of automation. And also there are time sensitive kind of a network which we may require. So there are multiple type of IoT which 5G has to support. So So to support some of the use cases, 3GPP thought of coming out with a capability called Redcap, reduced capability devices, which can work on any 5G network with certain software upgrade of the network. Okay. So please recall various 3GPP releases we had talked about. So the concept of Redcap came into release 17. Just see here, you can see this laser pointer. So in release 17, we talked about Redcap, and this is also called NR Lite. NR is new radio, the lighter version of NR. So please remember that we are not talking about creating a separate core for such devices in our Redcap. Rather, the concept is that within the existing infrastructure of base stations and the core, can we support devices which are reduced capability kind of a devices? So that's the concept which we will be talking about in NR Lite or Redcap today. And this was further improved, being improved in release 18. So you may not see the commercial equipment as of now related to Redcap, but maybe within 1 year or 2 years, many devices will start coming supporting the Redcap. Okay, so why there was a requirement of Redcap? So we saw various type of IoT devices, the massive IoT, uh, the broadband IoT, critical IoT, and the industrial IoT. So which of the problem can be solved by this 5G Redcap? And what is the need for that? So as I discussed that in 5G, we have three usage scenario. And for example, in enhanced mobile broadband, we support up to 20 Gbps peak speed and user experience data rate up to 100 Mbps. Uh, we support latency up to 1 millisecond and very, very high reliability of 6 9 kind of reliability. In massive machine type communications, we support about uh, 10 lakh devices connectivity. But these are not required for every use case. These are not required for uh, every use case. So we require a lesser capability. Okay. For example, let's talk about that. What could be minimum requirement? For example, if you talk about uh, uh, some devices, suppose you buy. So where what I'm trying to explain in this slide is that any standard 5G phone, if you buy from the market, what is the minimum specification it may have? So it must support 100 megahertz of the bandwidth, and also it will have four chain of antenna. So four RX antenna, 100 megahertz of the bandwidth. And so these requirements which are there in the 3GPP for any 5G device may not be suitable for many of the IoT use cases which I talked about just now. So, and why those are not suited for IoT device? Because I want a IoT device which should be of lower cost, lower complexity, and very, very high energy efficient. So this kind of standard specification, which is required to be in every mobile handset, are actually not required for IoT sensors. And this gives birth to the reduced capability devices. Okay, and this kind of requirements are also not suitable for low power wide area network, LPWA type of a network, if you want to make it using 5G. So let's look at some of the IoT use cases and what are its requirement in terms of speed, latency, energy efficiency, and so on. So let's start with industrial sensors. We talked about that industrial IoT for automation, etc., would be a requirement. So, and we don't need a very, very a high capability for those sensors. So what are the things required? So other type of device I'm talking about is the wearable device, the smart watch. You might be knowing about Apple smartwatch you might have seen. So those wearable devices can connect directly to the 5G, but those will also not require all the capabilities of 5G. So they'll require certain reduced capability devices. And finally, the surveillance cameras. Surveillance cameras, which you see in a smart city or otherwise, even individuals would be putting surveillance cameras, organizations would be putting. So that would also not require all the capability which 5G have. So what we actually require, so if you look at industrial sensors here, so 2 megabit data rate is good enough for those sensors. I don't require 20 Gbps speed. I only need 2 Mbps data rate. So why to design those sensors to support the high capability of 5G of 20 Gbps, which will increase my cost, which will increase the size of the device, and which will also be very complex and consuming more energy. In terms of latency, the 100 millisecond of latency is good enough for industrial sensors. I don't need a 1 millisecond latency. And even the reliability, which I talked about, 6.9 kind of a reliability, even the 4.9 kind of a reliability is good enough. That is 99.99% reliability. And in respect of the energy efficiency or the battery life of these sensors, I don't require 5 years or 10 years of the sensor life. I only require 2 years or 3 years kind of a battery life. So that is the requirement for which we are talking about having reduced capability devices. Kindly थोड़ी देर में कर लेंगे sir? Yeah, please. Yeah. Okay. The second kind of devices is the wearable device. Wearable device can be of many types. One is the smartwatch. Second can be medical devices which one can wear. Madhukar, if you can mute some of the participants are like their mic is on. So can you just mute that? So we require 25 megabit per second of data rate for wearable kind of a devices. Battery life expected is say 1 week, and it has to be a compact. That means if I have the full capability, I cannot have a compact device. And the third is about the surveillance camera. So surveillance camera would require say 150 Mbps of data rate. Battery life may not be because they may be connected directly on power, so may not be required of the weeks. And reliability required is also not very high. So considering these specific use cases and the similar use cases which can fit into these requirement, 3GPP has talked about Redcap devices, reduced capability devices. So, so here comes the concept of reduced capability, that instead of having EMBB, URLLC or MMTC, the devices will have reduced capability, and it can still connect to the 5G radio, 5G core for its working. Okay, so let's compare and what are the requirement and all. So just look at this particular picture. So in terms of EMBB, URLLC and MMTC, so high data rate that is 20 Gbps and 5G, whereas I am requiring say 150 Mbps maximum data rate to support a surveillance camera. Then the low latency of 1 millisecond may not be required. Even 100 millisecond latency is good enough. And then the low cost and long battery life for MMTC or massive IoT, we may not require 15 years. We may require only 2 years or week battery time. Similarly, the reliability, which should be 99.999, even the 99.9% reliability is good enough. And the 5G devices, normal handset, are very costly. Whereas if we support only the lower kind of capabilities requirement on a IoT device, it can become a low cost device from costly to a low cost. So this is the genesis of Red capability. Is my voice audible? Is my
Yes,
voice
sir.
audible?
Yes, sir.
There is a break, sir. Break in
There
one.
was a break, but now it's clear.
Okay, thank you. So should I repeat or you are I'm good to go?
Uh,
So the last
Okay,
point of the previous slide, please.
last point. So what I was trying to say that the 5G per se requires very high requirement for the devices in terms of data rate, in terms of latency, in terms of battery life, etc. Whereas there are many use cases which I talked about would not require those high capability. For example, instead of 20 Gbps, 150 Mbps is good enough. Instead of 1 millisecond latency, 100 millisecond is good enough. Instead of 15 years, 10 years of battery life, 2 weeks of battery life for smart watches and 2 years battery life for IoT sensors are good enough. Reliability of 6.9, which we had talked about here, 3.9 kind of reliability is good enough. And devices, normally 5G handset will be very costly, 15,000, 20,000. Whereas our IoT sensors supporting reduced capability can be of low cost. So that's the genesis of talking about Redcap. So, and that's why there are three requirement of these sensors: industrial sensor, wearable device, and serverless camera, for which RedCap is being talked about. That the device should be low complexity. That means the electronics inside should not be very complex. Then the cost should reduce. So if you have less electronics, less hardware, the cost would definitely decrease. And then it should be energy efficiency, how it can save power, how it can save more power compared to a handset, a normal handset. So how these has been taken care in RedCap specification, I'll just try to cover. Okay, so what are these reduced capabilities? So user equipment will have reduced capability to support low complexity, low power kind of devices. Okay, so as we saw that uh, 5G phone, a normal 5G handset has to support minimum of 100 megahertz of channel bandwidth in frequency range 1. Whereas we are saying that to support reduced capability devices, we will reduce this to 20 megahertz for RedCap devices. So the channel bandwidth I am reducing by 1/5 compared to a handset. So complexity and cost of the devices will reduce. In FR2, when a normal device supporting FR2, the minimum channel bandwidth we are talking about 400 megahertz, that it has to have 400 megahertz, whereas for RedCap devices up to 100 megahertz will be supported in these standards. Then there is a concept of carrier aggregation in 5G. So devices are supposed to support carrier aggregations, whereas the RedCap devices are not expected to support carrier aggregation. So this will also reduce the complexity and cost. And there is a concept of dual connectivity. All our 5G phones are uh, uh, are supposed to have dual connectivity once they are following release 16 onwards. Whereas for reduced capability devices, IoT devices, the dual connectivity requirement is relaxed kind of. Okay. Okay. The other requirement which are supposed to be reduced for such devices are the modulation level. So we have heard about that in 5G, the supported modulation is 256 QAM, 256 QAM in release 16. Whereas for RedCap devices, this is being reduced to reduced up to 64 QAM only, so that the complexity or processing power required in the IoT devices reduces. And 256 QAM is being made optional. If you have a high-end applications you can go for 256 QAM. Otherwise, 64 QAM should be good enough and can support those requirements which I talked about, that Redcap usage scenario would require how much data rate, how much latency, etc. Okay, similarly, if you look at a 5G handset, generally there will be a multiple receive and transmit direction in that. So those are also relaxed in case of a Redcap user equipment. So here we are saying that in FR1, only one RX chain is good enough, one RX and one TX. In FR2, uh, can be more, uh, and two kind of a receive in FR1 has been made optional for Redcap devices. Maybe some high-end devices can have double receive chain. Okay. And also, we are trying to support half duplex. If you have a FDD mode, so half duplex is supported. And finally, the RF design with all these features can be simplified. Okay. And then there is a concept of MIMO in 5G, you may be aware that, but for reduced capability devices, we are saying that there will not be MIMO, only one layer of UV with one RX. And the two layer is optional. Two layer is optional. Let me check. Yeah. So one and two layer both are allowed, but one layer is also good enough. So this will actually reduce the overall capability required for a IoT user equipment. Okay. So just let us summarize in one picture that how a legacy user equipment versus Redcap user equipment. So in legacy user equipment, you know that you have multiple trans and multiple receive, and you have a duplex filter. Whereas in reduced capability, we are talking about single trans and single receive, and we are also talking about not having a duplex filter. It can switch either transmit or receive. Not I will not do both simultaneously, even in FDD. So that's the reduced capability. And a legacy UV in FR1 has to support 100 megahertz, whereas a reduced cap device can support up to 20 megahertz. Similarly, you can have you are required to have minimum two layers of MIMO in 5G handset, whereas reduced capability devices is not required to suppose MIMO. Only one layer of transmission is good enough. The modulation level which a legacy 5G device has to support is 256 QAM, whereas the reduced capability device will support only 64 QAM kind of a modulation. So these are all reduced capability design, which we have talked about in release 17. And then for energy efficiency, there are certain techniques which was some of it was also there in 4G, some of it has been improved. So what are those? Let me first talk about. The first is uh, we call it DRX, discontinuous reception, DRX, and then it has been further enhanced. So we call it enhanced DRS or EDRS. If you look at the first point here, right? So generally, when your phone is in idle mode, so that is called idle mode DRX. So UV from periodically wakes up to monitor paging message and goes back to sleep mode if the paging message is not intended for it. So that means when a phone is idle and if you are using discontinuous reception, then it sleeps for some time and then look for the paging once it wakes up. So this also improves battery consumption. That is in idle mode. In connected mode, it is required that the user equipment must monitor control channel, physical downlink control channel in every subframe. That means in every 1 millisecond or half millisecond or 1/16th of the millisecond, depending upon the numerology. And what it looks for control channel, whether control channel is available or not, right? Uh, in connected mode, it's not CRX, it is DRX. Please, this is a mistake. So in connected mode, discontinuous reception, DRX. So what it does is that UV sleeps for some time, that is called off duration. And at that time, it does not monitor PD CCA channel, that is a control channel. And this sleep time can go up to 2.54 millisecond, right? It can go up to 2.54 millisecond. Otherwise, every say millisecond, it has to look for it. In case of a numerology 0, so it can go up to 2.54 millisecond. But when we talk about enhanced DRX, which came in release 17, so it is being improved for Redcap. So this duration is getting increased in connected mode, right? So for example, in case of a eDRX, enhanced DRX cycle, which will be available in release 17. So the device can go for a sleep for 3 hours in idle mode. When it is in idle mode, so basically RRC idle mode, we call it, it can sleep for 3 hours and then it wakes up and look for any data, right? And but in connected mode, suppose it is connected mode and there is a state called inactive. It's not transmitting data, but it's a in between stays between idle and connected. That is called inactive mode, which came in 5G itself. So there it can sleep for 10.24 millisecond in release 17. And then in connected mode, inactive mode, in release 18 also there is some enhancement happening and it can go to sleep for 3 hours. So even in inactive mode. So these all feature would actually improve a kind of energy efficiency for IoT devices, depending upon what kind of use case we are looking at. So these are various energy efficiency kind of mechanism which we can use in 5G for Redcap devices. Then, if you recall, we were talking about that when a mobile phone is on, so UV generally will connect to a base station or G node B. And actually it measures the signal and then select the strongest signal strength base station it connects, right? But it keeps on measuring signal strength coming from other base station, right? Nearby cells. And there is a cell reselection procedure wherein it switches the cell from one cell, it goes to other cell. Even in, I mean, even if you are not mobile, you are sitting at one place, depending upon which cell is the strongest signal I am getting. So what it does is that it selects the signal which has the strongest signal. So all these activity will take power or consume power. In case of a RedCap devices, these are kind of a relaxed. We call it RRM measurement. So these RRM measurements are relaxed for RedCap devices. Frequency has been reduced. Suppose a RedCap device is a stationary device, like you have installed a camera, right? Video camera at fixed location. So there will not be any mobility, zero mobility. In that case, even RRM measurement is not required because it will always connect to one base station. So why to keep on measuring other cell when that device is not moving? So these are certain relaxation which applies to RedCap devices, and these are managed over the air in the sense that uh, for a particular device which is requiring these capabilities, uh, RedCap kind of devices, those only will get all this relaxation. So you can read more about RedCap, which was talked about in release 17. So this document is 38.875, readily available on 3GPP website. You can search on Google, right? So it's about study on support of reduced capability new radio devices. My slides are primarily based on these standard. So let's have a conclusion. So So once we have Redcap devices, it will open up more new use cases and it will broaden the 5G ecosystem. Then it will fill the gap between low power, wide area kind of a network for massive IoT and the extreme requirement of URLLC. It comes in between these two. Uh, so 5G RedCap and enhanced RedCap modules will be very, very cost effective, and I can make a less complex device or less costly device with this capability. Uh, and if you compare these devices from LTE, so LTE based IoT, so here we are improving on those. So latency will be better and speed would also be better compared to LTE. So it will be somewhere between LTE and full capability 5G. So it's a mid-tier kind of devices. So with this, my first session is over. Maybe uh, we can have certain questions or if you need anything else. So can you open your kind of videos and have question answer before I start uh, the next session, which is like about integrated access and backhaul.
Sir, I have one question. I'm
Yes, please.
experiencing from it.
Your voice is slightly less. Can you be near to your mic
1 minute.
or?
Yeah, am I
Uh,
audible now?
yeah, now very clear. Yes.
Sir. So I have a one question. So in your one of the slide where you have identified some parameters, we require, let's say, latency of this much, and
Yeah.
some more parameters were there. So is there any standard way to identify those parameters? Means my question is how they are identified actually with respect to URLC, EMBB,
So,
and
okay.
mm.
So as part of 3GPP, the study was conducted that these categories of three categories they had identified: industrial IoT, wearable devices, and the surveillance camera. So what they thought that can we come out with these reduced capabilities like having supporting 20 megahertz only instead of 100 megahertz, supporting only a single layer of MIMO, no MIMO single layer, only one receive and one transmit. I don't need full duplex, half duplex. So these were studied in the paper which I discussed. So there they decided, I mean, in that study paper that what should be a common minimum reduced capability requirement. So there will be certain changes on the infrastructure that infrastructure should support those requirements. For example, I talked about DRX and enhanced DRX that devices can sleep for a longer time. So there is a talk that maybe in future a device can sleep for 6 months even. There could be certain use cases where periodicity is not there. So those are already defined in the standard release 17 standard. And now OEMs are trying to build the applications or the UV devices and upgrade in the core side so that it can talk to the core with reduced capability setup itself. So as such, what will happen? The current infrastructure which operators may have, 5G infrastructure in terms of radio or in terms of core, those are not required to be changed. Only some minor software upgrade would be there. So one has to bring the core to that particular release to support these features. And newer devices will come into the market, right? Maybe the wearable devices, surveillance camera, which will have built-in 5G eSIM, which can directly work uh, by connecting that, and once you have related servers for that. So I hope I answered your question. I
Yes, sir.
don't know.
Yeah. Yes.
Anything else? Any more question or
Sir, practical application. Good morning, sir.
very good
Um,
morning?
This practical application connecting to today's your lecture and yesterday evening madam's lecture.
Yeah.
The application of this reduced capabilities kind thing will come in edge computing. We can use it and
Yeah.
we can work out with the large data and capabilities in the cloud-based systems. so that we
Okay.
can integrate the massive applications using the 5G technology. Is there any direction of research in this part?
Yeah, definitely. So 5G provides you the kind of a
Capability.
connectivity with lower latency, higher speed, or reduced capability kind of support, right? Now, suppose someone is working on an applications. For example, suppose Apple will be coming out with their devices, with their wearable devices, right? Which will have many features like it can do ECG, it can do many other health related benefit or activities. So they would be required to also have their servers supporting these services located near to the user. So they would be, so initially they may not have edge server, but later on, once a customer grows and they want to provide more and more services, fast services, they would be deploying edge server to support that. Now there are two kind of such use cases. One is that you are connecting to public network. So a smartphone will always connect to the public network because you will be moving all around, and so on a public network, having edge computing for every service will take certain more time because you have to collaborate with operator, put your server inside the operator's UPF, I mean data center where they have user plane function. But there are other use cases which is private 5G or campus 5G or industrial 5G, which is a private 5G network. So for example, if I am using this Redcap industrial sensors for a private 5G industry, then I'll not be using the public network. I'll build my own 5G network inside the industry, inside my factory, and then I'll have my own edge server because all the applications through which I can control robots, through which I will operate all those
Right.
sensors are my server. So those would be located at the edge. When we say edge, we are just saying that from the 5G, wherever you have user plane function, please co-locate your server also and connect there so that there is no latency between the two. You are at the edge itself and you can service give more. So the research part which you're talking about, so think of some application using 5G, maybe your 5G lab, right? And then build that particular application. Suppose I talk about agriculture, right? So in agriculture,
Yes,
I can
precision
think about
agriculture.
many applications using sensors data which is
Yes, sir.
coming. So those are the data which can come through any connectivity, say 5G, for example. Then now all the processing of the data using AI ML on top of that, your edge server should do, and the insight can go to the farmer, or you can recommend that which
Yes, sir.
pesticide to put or which
Yes, sir.
medicine to be put. So those are the area where we have to work. I need not reinvent 5G, right? So I have 5G
Yes, sir.
network. Now applications I can develop. For example, if you recall, I had talked about the drone platform which Qualcomm has developed. So
Yes,
a small
area.
device which can fit into any drone, and it can connect to the 5G network, right? Maybe your private 5G network, campus network. Now, if I had to build an application related to agriculture, related to army, related to defense for surveillance, I need to build my own server, own applications using so
Right,
5G
sir.
will only provide you connectivity and you'll have a online data with less latency. How to use, you can create your own application. So that is a research area where one has to look for that what problem I can solve with these features. So the use case is a definite research area. The other research area is like for 6G. Suppose you want to do something for 6G and you already have a 5G infrastructure. So you can
How
think
we
of,
can learn.
can I improve, can I use some a new waveform which will give me more efficiency, more data
Right.
rate? Can I use certain spectrum which is not being used for 5G? So what kind of
Right.
use case I can have? So in 6G, I have talked about, we have talked about a new capability of sensing, right? So what kind of application or thing I can think of, and in case I'm able to do some heads up, I can go to 3GPP ITU, submit my research into the standard. If I have created some IPR, I can go and submit onto the 3GPP standard. We'll try to make it standard essential kind of a IP, so that once those equipments are sold, money will come to you, money will come to those having the patent, etc. So those are the research area in my opinion.
Thank you very much, sir. Well
Thank you. I
explained.
think there is
Because
one more raised hand. If somebody
Sir.
want to speak.
Sir,
Yeah.
one small question. Is there any other standard other than TR 38.875, which deals with NR, reduced capability for NR devices? Anything related to floor?
So this talks about all places. So if you read this document, it will also give you all cross references. I think it's the best document to read.
Okay, sir.
It's
will
not
go
a
through
big
it. Thank you.
document, it's a small one. So this will give
Yes.
you a lot of cross reference, and you can search many white paper. So there is one white paper from 5G America. If you type on Google, you will get it. That Redcap 5G America. Ericsson has also a paper. So in my slide, there was a link given. Ericsson link was given. So you can read that uh, if it was there. I don't know. I mean, so whether I remember, I
Yes,
can
sir.
also pass on those PDF which I have on the shared folder. I can pass those on also. So no issue on that. Maybe after the session, I'll try to pass it on.
Yes, sir. Thank you. I think the document name riding the next 5G wave with Ericsson Redcap.
So I mean, there are many white papers by OEMs, by researchers like Qualcomm and all. Qualcomm has also got so many videos, so many things on that. But my request to all of you, that if you read different papers, they may talk about here and there many things. But once you read this 3GPP document, you become clear that what was the genesis, how they have thought of, right? So there can be bonus use cases also using this rate cap, right? So 3GPP has talked these three. Others will also be talking about many other use cases which rate cap can support, and that is true. So we should read both 3GPP paper and then combine this with other white papers and other papers by others. So that gives a broader idea about this particular feature.
Thank you. I will go through it.
Okay, thank you. So there's a raise hand by Dibya, NV Dibya. So please go ahead.
Yes, sir, my question is, can you please repeat or elaborate on how it is different to use 100 megahertz on FR1 and 100 megahertz on FR2? Or to put it in another way, given we have a 100 megahertz use case, how or when do we decide which of these FR1 or FR2 to use?
Okay, so two things I would like to explain, that when you buy a 5G phone today, a normal device, normal 5G device, so 3GPP has set a minimum requirement, although 5G supports up to 400 megahertz and also supports carrier aggregation, so many features, but they have put something minimum which every phone must have, right? So those minimum in terms of channel bandwidth support, it is 100 megahertz, right? So the chipset which are available for any manufacturer today, a 5G chipset, maybe from Qualcomm, maybe from MediaTek, what you get is a chipset which will support 100 megahertz, minimum 4 layer of transmission. That means 4 transmit and 4 receive chain would be there in a 5G phone, right? Just a moment. अभी रख दो, लगाना बाद में है. आ जाना दोपहर 1 बजे के बाद. Sorry. Okay. Similar are the feature in terms of what kind of modulation, which QAM, 256 QAM has to be supported, and full duplex has to be supported in case of a FDD channel. But if you build a IoT device using the chipset which has gone into these devices, even the minimum standard one, your device will be very costly. The IoT device will be very costly. It will be very complex. It will consume a lot of power. So to support reduced capability devices in release 17, 3GPP agreed to certain relaxed kind of requirement for particular use case of industrial IoT, surveillance camera, and wearable devices. So they have come out with some minimum requirement, MVP, minimum viable product kind of thing, where I will support only 20 megahertz channel bandwidth. I have only one layer of transmission. I'll support half duplex. I'll support only up to 64 QAM modulation and so on. Okay. So now the third question is that how my network will understand that a particular IoT device is a reduced capability device. So there is something called UV capability ID. I don't know whether the Chinese ma'am talked about in her class. There is something called UV capability. So every user equipment device has what are its capability, UV capabilities, maybe in terms of spectrum band supported, maybe in terms of how many transmit receive antenna it has, and so on. So during the initial call setup, these are exchanged to the core, radio and the core. And then based on what this device is capable of, network offer you services. So for Redcap devices, network will come to know that's a Redcap device. Is what it can towards the core that it should support Redcap devices once it gets Redcap parameter from those IoT devices. So did I answer your question?
Yes, sir. And I would also want to know, using 100 megahertz, I mean, maximum bandwidth on FR1 versus using reduced bandwidth on FR2. So is there any literature which talks that reduced capability has advantage over this?
Yeah, so please read that particular 3GPP document, which I put the number in the slide that is shared also. And I think I'll have PDF copies. I'll put it in the shared folder. It gives a detailed study on each parameter, why they are choosing a particular thing and why what benefit they'll give. There are certain benefit analysis also that how much power reduction will take place. And there are certain white paper which gives you that how much cost reduction will take place once they do reduce capability. So those studies are there. So maybe I'll put those white papers also onto the shared folder so that you can go through. Will that be okay?
Okay, sir. Thank you.
Thank you. Any more question or shall we proceed? Okay, if there is no more questions, so yeah, please go ahead, sir.
Proceed, sir. That's fine.
Okay, so let's do one thing. Let's have 5 minutes break so that everyone can take a small break and then we'll start. And in the meantime, I'll load my PPT. Just a moment. Madhukar,
Yes, sir. Yes, sir.
you can stop the recording, previous one, and this one we can start maybe after 5 minutes.